A run chart is used to observe process performance over time. It is a line graph with data that vary around a center line, usually the mean. It is used for repeatable processes where performance is expected to be stable. A run chart will show defect trends, shifts, or cycles. To create a run chart, first we need to identify the process to be observed. Make sure the process involves some kind of repeatable activity, in which results are expected to be consistent over time. A run chart has no value in areas where data are expected to change, as in a chart showing profits. The second thing we need to do is collect data. Usually 20 to 35 data points are required for a meaningful chart. The third step is to create the graph. As stated, a run chart is a line graph with data that vary about a center line. Plot the data on an XY axis graph, then calculate and plot the mean. The fourth thing we need to do is interpret the data. Look for trends, shift in data groupings or cycles. Consider commute time, or the time required for project team members to travel from their homes to the office. The task manager has noticed that tardiness has been an occasional problem, but has some regular aspects. When one person is late, many seem to be late, and it seems that some days of the week have a higher incidence of tardiness than others. He would like to see people at work on time and is tempted to issue a directive with a threat of punishment for late arrivers. But he thinks there may be factors beyond employees' control that are affecting arrival times. He collects data from all employees for a 20-day period. He computes daily averages and plots the data on a run chart. The run chart shows a repeatable process. People commute to work every day. It also shows a process that is expected to be rather stable. Travel time may vary according to traffic and weather, but generally the commute time should be about the same every day. The first thing that the task manager notices is that there are two spikes, examples of extreme deviation from the mean. He recalls that a truck overturned recently and closed the main highway for several hours during morning rush hour. The run chart shows an average of 120 minutes for the commute on that day. A few weeks later, a federal holiday occurred on a Monday. Many businesses were closed, but not the project office. Team members experienced a significant shorter commute due to reduced traffic. After a little more study, the task manager notices a regular pattern of data points significantly above the mean. These points occur every Friday. Seems reasonable, he thinks. Traffic always seems to be heavier on Fridays. He is about to send an email to all team members advising them to get an earlier start on Fridays so they can arrive at the office on time when Amy stops by his work cube.
Jim, got a minute?
Sure, what can I do for you?
Well, remember last week when you asked Larry to collect data from all of us about our morning commute time? I asked Larry to give me a copy, and I have prepared what's called a run chart. It shows how data vary over time, but more important, how data vary around a center line, usually the mean. Take a look at this chart. Other than the two exceptions, the day there was an accident and the day of the federal holiday, it shows that Friday is consistently a bad commute day. And we see that in the office. A lot of people are late on Fridays, and everybody is generally out of sorts because of the bad commute.
Yeah, I know. I made a similar chart and I was just about to send out a note telling people to get an earlier start on Fridays.
Jim, that's going to be a lead balloon. I've got a better idea. Why don't we adopt a flex time schedule where people can work extra hours during the week and take a Friday off every period? Or better yet, why don't we do telecommuting and allow people to work from home on Fridays? We'll contribute to reducing traffic, save fuel consumption, and make people a lot happier. And I'll bet a lot more productive on Fridays. What do you think?
The task manager thought Amy had a pretty good idea. It was an idea that made sense to him because of the data, and it was an idea that he could propose and defend to the project manager because it was based on data, not intuition or personal choice. The matter of contract processing time provides another example, perhaps one more closely related to project actions. Previously, the task manager used a histogram to understand the data, to see how processing time was distributed across the range of values. Now he uses a run chart to see how processing time varies around the mean. He collects data for a 20-week period. For each week, he calculates the average processing time for all contracts that were processed to completion during the week. He plots the data on a run chart as shown here. The task manager has just heard that the program manager told him that the vice president for operations wants all contracts processed and awarded by the end of August, so that the contracting office can use September to put everything in order in preparation for the new fiscal year that begins on October 1st. He wonders if these people ever made decisions based on data or even considered the directives have on the workforce. He knows that September is always extremely unpleasant for his friends in contracting because of all the extra hours required to meet his annual management directive. And he knows that he and other task managers make the situation worse by dumping as many contract actions as possible on the contracting office late in the year, knowing none will be processed during September and will have to be completed by the end of August. Looking for a better way, he begins to analyze the run chart. Because the average processing time is 42 days, his first thought is that the contracting office should stop accepting new contract actions 42 working days before the end of August. That means around the 1st of July, but that is only the average. Contracts requiring more than 42 days to process would still create extra hours of work in order to be completed unless an equal number of requiring less than 42 days were in the queue. Maybe the cutoff day should be 52 working days before the end of August, an amount of time equal to the highest number of days shown by the current data. This does not seem like a good solution. Besides, the contracting office is likely to announce that it will stop serving customers on the 1st of July or before. The task manager takes another look at the scatter diagram prepared earlier to determine that contract processing time seems to be related in some way to the dollar value of the contract. After a little thought, he decides that the best solution is one that involves all the participants, not one that just dumps the problem onto the contracting office. He develops a progressive schedule of lead times for distribution to task managers. Lead times are based on expected processing time related to contract value. This schedule will advise task managers that if they anticipate a contract action of a certain amount, they should have the action to the contract office by a certain number of days before August 31st. Now, task managers will have information they can use for planning. The contracting office will probably receive contract actions within more reasonable time frames, and the contracting office can extend receipt of low dollar value contracts into September because of a short available processing time. All of this is possible because the task manager applies quality tools to understand data and processes: a histogram, a scatter diagram, and a run chart.